Welcome back. This is Mr. Hassan's Maths channel. I'm now answering a question number 6 from the June 2018 Edexcel Core Mathematics C3 paper, which is the old specification, which this question is basically now part of P3. And this question here is all about addition formulae and trig identities and equations. So in this question, we are asked to use the identity for tan A plus minus B to solve for x values between minus 90 degrees and 90 degrees. This equation, tan 2x plus tan 32 over 1 minus tan 2x times tan 32 equals 5. Giving the answers in degrees to 2 decimal places. So there's something which we have to take note of, because normally, if it's not stated, we give angles and degrees to 1 decimal place. So just make sure that you don't want to throw away marks. Keep that in your mind right from the beginning. Because sometimes while you've gone through all the process of answering, you get the answer at the end, you don't, if you don't keep this in your mind, you forget and you just throw away a mark. And that mark can be the difference between an A star and an A in the A-level maths. So you have to be very careful not to throw that away. All right, so now, it says use identity for tan A plus B. So if you go to the formula book, you'll see there's the trig identities, and the one that they're pointing us to is this one here, the identity for tan A plus minus B. So we need this identity, okay, for us to solve this equation. They've told us, to get that. So we have this identity here, right? And I'm going to keep that on the side. So that's the formula. We've looked at the formula book. We found the identity we need, and then we're going to apply it. So it says here, tan A plus minus B equals tan A plus minus tan B over 1 minus plus tan A tan B. So what that means is basically, if we look at the form of this, you've got a plus on the top and a minus on the bottom, right? If you look at the form of what we have here, the plus, we have the plus and then the minus. I need to make that thinner, I think. So we have the plus and the minus in the denominator. So it's going to be of the form of what's on top, which is a plus. Okay, so we can see that it's going to end up becoming something tan something plus something. And here we can see that the A, instead of the A we have 2x, and instead of B we have 32 degrees. Okay, so the A is our 2x and the B is our 32. So if we take this tan of 2x plus tan of 32 degrees over 1 minus tan of 2x times the tan of 32, we can rewrite it in this form here as the tan of, and A is 2x, and we're going to have plus 32. All right, so now we simply have our equation becoming the tan of 2x plus 32 equals 5. So we have to basically solve this equation. Simple as that now. So once we got it in this form, it becomes a simple, P2 type of trig question. Solve this equation. Tan of 2x plus 5 equals 32 degrees. But we have to solve our x values between minus 90 and 90. So what we have to do, remember, if we have a compound and multiple angle, which you have, this is a mixture of both, we have to change the limits so that we don't lose any solutions. So I'm going to make this has to match what's written here, has to match this, has to match what's in this part here. They have to be the same. All right, so I have to write this as 2x plus 32, and I have to change the limits accordingly. So I have to, here you have to multiply the x by 2 and then add 32. I must do the same to minus 90 and the same to plus 90. So I'm going to do that. I'm going to do 2 times minus 90. And then I'm going to add 32. That gives me minus 148. So that's my lower limit that I'm going to go to. I can't get any angles less than that. And the upper limit will be when I do 2 times positive 90. So I'll just go back and change that to a plus. And that gives you 212. So I can't go more than 212, and I can't go less than negative 148 in gathering my solutions. So now I'm going to have 2x plus 32 equals the inverse tan of 5. Okay, basically what we've done, we've taken the inverse tan of both sides to get rid of this tan, and we're left with this. Now, It says in degrees. Okay, so we have to make sure our calculator is in degree mode. So let's just make sure. the calculator is in radian mode. So I'll press Shift and Menu and Angle Unit, which is 2, and Degree, which is 1. So now we're in degree mode. So now we've told the calculator, please give us the answers in degrees. So now I'm going to press inverse tan of 5. So Shift, tan, 5, and then that will give you my first solution, which is 78.690. I'll write it to more than 2 decimal places because we want it to 2 decimal places at the end to round. So 2x plus 32 equals 78.6901. I'll put 2x plus 32 equals, I forgot already. 78.6901. 78.6901. Okay, that's our main solution. Okay, that's our main solution. Now with the tan curve, we know that it repeats every 180 degrees. If that's minus 90 and that's plus 90, this is for the normal tan curve. It goes like this. It goes like this. Every 180 degrees it repeats. So we've just found an angle somewhere over here. Okay, where tan theta equals 5. We found this is 70. Can't even read my writing there. 76, 78. Let me just make that a bit neater. 78. 78.6901. Okay, so that's 78.7 for now. All right, now we can see that the tan curve repeats every 180 degrees. So the next place where it's going to have the same as this tan ratio is going to be over here, which is you have to add 180 to it. So you got to add 180 to this. Now, if I add 180 to this, that's going to be more than 212. That's going to be 250. So that's going to be out. So we can't take that angle. If I take away 180 from this, I'm going to be getting the angle over here. Now, 78 minus 180, I think it's going to be in the range. So let's figure that out. We have this, and we're going to take away 180. And that gives us minus 101, which is in our range. Our range goes up to minus 140. So we have the other angle, which is minus 101.3099. Minus 101.3099. Just make sure of that. That's right. Okay, so that's the other angle. So those are the two angles in the range. If I, of course, go back another 180, I'm going to be outside of the range. So those are the two angles inside our range that we need. Okay, so now I'm going to find what x is. So I have 2x plus 32 is equal to 78.6901 and also minus 101.3099. So I've caught all the angles in our range. Now, when I find what x is, I have to do, basically, you have to subtract from these two angles, 32 and divide by 2. Subtract 32 and divide by 2 for both of them. So minus 101.3099, take away 32, and divide by 2. That will give me my values of x, which should be in our actual range between minus 90 and plus 90. Okay, so now I'm going to take this, I'll take this angle here. So, okay, now let me just do this again. Okay, I'm going to, all right, this is my first angle. So I'm going to do this. I'll put answer minus 32 divided by 5. Okay, that gives me 9.3380. 9.3380. And this will give me, I go back to this and I subtract 180. Okay, that's the angle that we got. So I'm going to put answer minus 32 over 2. That gives me minus 66.655. Minus 66.65. What was it again? 6549. Let's keep it like that. All right, so we want to round it to 2 decimal places. Okay, to 2 decimal places. All right, so this is going to give you x equals 9.33, and this is going to be minus 66.65 degrees. So those are the two solutions, okay, from this problem. And you can see the angles in the end are between minus 90 and 90. Okay, so that's how we solve number 6, part 1. Okay, using, first of all, the addition formula for tan A plus B in order to rewrite this in a way that's easy for us to solve. Okay, so that's part one done, and now we're going to go on to part two. Now, part two says, first, again, using the identity for tan A plus minus B, which I've got over here, show that tan of 3 theta minus 45 can be written as tan 3 theta minus 1 over 1 plus tan 3 theta. So we're going to use the one which has a minus. So we're gonna use the identity tan of A minus B is equal to, and on the top it will be tan is going to be a minus still, so it will be tan of A minus tan of B, and underneath it's going to be with the plus, because there's a minus here, there's a minus on the bottom, and there's a plus on the bottom of this one, so it's going to be 1 plus tan A times tan B. Okay, so how do we apply this? We can see from here that the A is 3 theta and the B is 45 degrees. Okay, so we're going to have the tan of 3 theta minus 45 degrees is equal to the tan of 3 theta, get a bit neater, the tan of 3 theta minus the tan of 45 degrees divided by 1 plus the tan of 3 theta times the tan of 45 degrees. And what we should know is the tangent of 45 degrees is equal to 1. Okay, so therefore, let's make some more space here. Therefore, we can say that this is going to be equal to, this is 1, so you have tan of 3 theta minus 1 over 1 plus tan 3 theta times 1. So it's 1 plus tan of 3 theta. So this is what this, we've shown how that comes, right? So you have to show your steps carefully, you know, make sure you mention tan 45 equals 1, and then you've got your answer. All right, so you've shown that this gives you that, okay, and using the identity. That's part A, easy 2 marks. And then it says part B, hence solve. Okay, let me just make a bit of space. Hence solve for theta between 0 and 180, this equation here. Okay, this equation here, sorry. So what I'm going to do is I can see that here I've got tan 3 theta minus 1 over 1 plus tan 3 theta, which becomes this. And here you have 1 plus tan 3 theta times tan theta plus 28 equals this. So what I'm going to do is make them look the same. So if I divide both sides by 1 plus tan 3 theta, this will leave me with tan of theta plus 28 equals tan of 3 theta minus 1 over 1 plus tan 3 theta. And this is the same as tan 3 theta minus 45. I can replace these two because they're equal to each other, as we proved in the first part of the question. So now we're left with the tan of theta plus 28 is equal to tan of 3 theta plus or minus 45. Okay, so we have here, this is, one scenario here. So we have tan of this angle, and we've got to find all the solutions between 0 and 180. Okay, between 0 and 180. Now, if we take the inverse tan of both sides of this, that should give us one of the cases where this will be equal to each other. So if I take the inverse tan of both sides, I'm left with theta plus 28 is equal to 3 theta minus 45. Now let's see if this angle is going to be within our range. So we have to solve for theta. So I'm going to do 28 plus 45 equals 3 theta minus theta. So that's going to be 60, 73, right? 28 plus 45. That gives you 73. So 73 degrees is equal to 2 theta. Therefore, theta is equal to 73 divided by 2, which is in our range. That gives you 36.5 degrees, 36.5 degrees. So that's one solution. It's in our range, so that's okay. So now, once we've got this first angle, theta equals 36.5, okay, there are other angles in the range. Now, our range is between 0 and 180. Okay, as the question says, between 0 and 180. So how do we find this other angle or other angles in the range? Well, we should know that the tan of an angle, okay, repeats every 180 degrees. The tan curve repeats every 180 degrees, as we know, right? So the tan of this angle will equal the tan of this angle, right? Now, if I add 180 to this angle, so I have theta plus 28 plus 180, tangent of this angle should also be the same as the tangent of this angle as well. They should give us the same ratio. Okay, so if I add 180 to this angle, it will give me the same ratio as the tan of this angle. It'll give you exactly the same ratio. All right, because we know that the tangent curve repeats every 180 degrees. Even if I take away 180, it will give me the same. All right, however, I want to stay in the range. So let me start with adding 180. So I have theta plus, that's going to be 208 equals 3 theta minus 45. Okay, because again, we can take the inverse tan of both sides to get rid of the tan. The tangent of this is equal to tan of that. That means this must be the same as that. So now we can work out what the angle is. We can say 208 minus 45 is equal to 3 theta minus theta, which is 2 theta. So we can say, therefore, theta is equal to this divided by 2. So let's work out what that is. So we have 208 minus 45 divided by 2, which gives us 81.5. Hold on. We have to add 45. Sorry, what am I talking about? That's my bad there. Start. Okay, so now what we can do is you can take the inverse tan of both sides. So we have theta plus 28 plus 180, which is 208, is equal to 3 theta minus 45. So to solve this, I'm going to add 45 to both sides, and I'm going to take away theta from both sides. So you end up with theta is 253 over 2. Okay, so therefore theta is equal to, so we have, let's just make sure we have 180. So we have 28 plus 180 plus 45, and we divide that by 2. That gives us 126.5 degrees. 126.5 degrees. That's also in our range. We could also say that I'll put this on the side here. Theta plus 28 will also give us the same as 3 theta minus 45 plus 180, because 180 more than this angle should give us the same tan ratio as that. So we can say the tan of this is equal to the tan of that. So these two will be equal to each other, and that should also work. However, we have to be careful that we stay in the range. So in this case, we'll have 2 theta on this side. On this side, we'll have 28. We'll have basically 28 plus 45 minus 180. So we'll have 28 plus 45 and minus 180. Okay, and of course, that's going to give us a negative angle. So we divide that by 2. Okay, that will be an angle that is true in terms of solving this equation, but the angle theta is outside of our range. Here, theta is negative 53.5. So we're not going to go that way. So if we add 180 to this angle, that takes us out of the range. So we're only going to stick to this side over here. So we don't need to go that far, right? So those are the two angles in our range. And we can always check to see if those angles are correct by substituting them back into this equation. So for example, you could, if you wanted to, check that these are both solutions. You could say, let's find out what the tan of 36.5 plus 28 gives you. It gives us 2.0965. 2.0965. I'll just write it over here. 2.0965. And you can also check with this angle, you have the tan of 126.5 plus 28. That gives you minus 0.476. Now, that's 126.5 plus 28. Now, let's see if that gives the same in this equation here. Okay, so we're going to take the tan of 3 times our angle and minus 45. That gives us exactly the same. You see, these two give us the same thing. So the tan of this angle plus 28 gives us the same ratio as 3 times the tan of this angle minus 45. So with this angle satisfies this equation, as does this angle. Both of them satisfy this equation. All right. And we can verify this one again. We can put this in here and replace this with 36.5. And it should give us what we wrote down over here. So when you put 36.5 in here, you get this answer. And when you put 126.5, you get minus 0.4797. The same thing when you put this into both of these. So we can see that those are two angles which satisfy this equation. Two angles which satisfy this equation. So we can verify in the end to be sure that we've done the right thing. All right. So basically, it's the first solution is just simply, equating these two and then saying, okay, we want, if the tan of something equals the tan of something, those two things must be the same. So you can simply equate those two angles to each other, find what theta is. And secondly, we can notice that the tan of an angle repeats the same value every 180 degrees. So if I add 180 to this angle, it should give me the same ratio as that. Okay, so I added 180 to it, and then I solved for theta, and I found that that satisfies the equation also. And you can also add a 180 to this angle, and the angle that we found would also satisfy both the equations. However, the theta we found would have been outside of the range. So these are the two angles in our range. So it's a bit kind of complicated, this last part. A lot of students have problems with that. I hope that made it a bit clearer for you. So that's end of question number 6 from the Edexcel June 2018 C3 paper. Other questions which I answer from this particular paper will be found in the playlist that will appear at the top over here. Other questions from this topic of trig identities and equations from P3 can be found in the playlist that will appear over here. You can subscribe to my channel by clicking on this link, and you can watch the video, the link for which will appear over here, which tells you how to use my channel in an efficient manner. Thank you for watching, and see you soon.